What? So,
Okay, so we were doing the different types of the formulae. We discussed about the structures and we also discussed previously हमने इससे पहले namings का भी discuss किया था. We'll now continue from here. The stereoisomerism. Stereoisomerism is basically a type of the isomer in which we represent the 3D orientation or 3D representation of the molecule. The 3D representation means we have to represent which bond is coming out of the plane, which bond is coming into the plane. That is a topic which you have already studied in your unit 3 chemical bonding, where we represented the type of the bond in terms of their 3D space. So basically isomers में 3D space का मतलब ये होगा the orientation of the bond in the space is different. Molecular formula same होगा, लेकिन सिर्फ और सिर्फ उनकी जो स्पेस में जो बॉन्डिंग है into the plane या out of the plane वो different होती है. But here over here we will also say that stereoisomerism is further divided into two further isomerisms. The one type of isomerism is the geometrical, or we can also call it as cis-trans isomerism. And the other type of isomerism is the optical isomerism. Now, these two topics are very important topics in the AS organic chemistry. We have to make formulas of the compounds on the basis of these two isomers. That is the trickiest part for most of the students, that they have to visualize how the not just visualize, they have to understand where a kind of isomer will be there because of the cis trans and because of the optical. मैं कभी वर्ड यूज करूंगा cis trans, कभी मैं यूज करूंगा geometrical, क्योंकि दोनों का मतलब सेम है. And optical isomerism is different. These two are new topics in as compared to O levels. Now looking towards the geometrical isomerism or cis trans isomerism. This is a type of the isomer which is observed when we have carbon-carbon double bond at any point of the organic molecule. Whenever we have a double carbon-carbon double bond at any point on the organic molecule, then this double bond will restrict the movement of the molecules present on these carbon atoms. Let's suppose I say that we have A, B, and XY bonded on these carbon atoms. They are not easily moved in all the directions. They can only be rotated over here. We can rotate like this, we can rotate like this. So because of this restricted movement, they have isomers. They are not free to move. They have the restrictive movement over here. Now, we have two types of the isomer because of this reason. We have the cis isomer and we have the trans isomer. These cis and trans isomers basically have different physical and chemical properties. And these physical chemical properties also dictate their type of the reaction or rate of the reaction. That physical and chemical properties will be discussed in detail in A2 level. That A2 level covers this part, the reactions or the properties of the cis and trans isomers. But currently in AS level, we are going to look into the isomers being formed by the carbon-carbon double bond. Okay, so here we have taking the example of butene. This is the structure of butene. We have carbon-carbon bond, double bond, and there are in total 4 carbon atoms. If you move from one side to the other side, we have 4 carbon atoms. and at position number 2 we have carbon-carbon double bond. So this is butene. Now we will see how this makes cis isomer and how does it make trans isomer. For simplicity, I will consider this type of the structure right now to make it easier for you. I will go through this molecule first. You can see here that carbon-carbon bond पे हमें कार्बन-कार्बन बॉन्ड पे क्या नजर आ रहा है? एक कार्बन के ऊपर A और दूसरे कार्बन पे भी A bonded है, which means these two are similar atom or groups of atoms. These are similar. A. On the other hand, इसकी जो दूसरी बॉन्डिंग जो हो रही है, this carbon is making bond with B and this carbon is also making bond with B. So this B is different from A, but this B is similar to this B. दोनों कार्बन पे we have two different groups. Accordingly here these are different groups. These are different to each other, but they are similar to the other carbon. These are similar here. So between these two carbon atoms, two groups will be similar and two groups will be similar. But अगर हम दोनों को आपस में कंपेयर करें, they will be different from each other. अब इस केस में हमारे पास जो अभी इसकी कॉन्फ़िगरेशन बनी हुई है, जैसे कि हाउ इट अपीयर्स, वो ये है कि both the A groups are on one side of this carbon-carbon double bond and both the B's are present on the other side of the carbon-carbon double bond. पहले तो हमने बता दिया कि this carbon has two different groups या atoms, उसी तरह इस कार्बन की two different groups और atoms, but they were similar to each other. अब हम ये बात कर रहे हैं कि दोनों कार्बन के जो similar atoms हैं और groups of atoms, they are present on one side, और इसी तरह there B atoms or groups are present on the other side. This type of the configuration is called cis isomer. This is called cis isomer. Now we will make another isomer that will be called trans isomer. If we have cis isomer, then we will definitely have a trans isomer. अगर हमारे पास कोई एक होगा तो दूसरा definitely होगा. Just like we said in electrochemistry chapter that if we have an oxidation reaction in a reaction, then there will definitely be a reduction reaction. In the same way, if we have a cis isomer, then definitely there will be trans isomer. So how would we make the trans isomer? For trans isomer, let me draw on another space. Carbon, double bonded carbon. I will write A in the same way over here, but over here I will I will have B over here, just like this. A and B will remain same. But on this carbon, I will have B over here and A over here. So what I did, I flipped these two positions. Or you can say I rotated this compound, either clockwise or anti-clockwise. So during the rotation of this side, मैंने पूरे molecule नहीं किया. I just rotated this part, not that part. So because of this, these two positions are now flipped. As a result of this, you can see that now both the A's are present on the opposite directions. They are opposite to each other. And in a similar way, both B's are now on the opposite directions. It is in this direction, it is in this direction. And same goes for A. This type of the configuration or isomer is called trans isomer. This is a trans isomer. Now I will go back to the previous example. This is called a cis isomer because we have the CH3 group. पहले तो हम बात करेंगे which bonds, which molecules or atoms are there present. This carbon has CH3. This carbon has also CH3. This carbon has hydrogen, which is different from CH3, and this carbon also have a hydrogen, which is different from CH3, but this is similar to this H. So we have this arrangement. Over here, we have both the CH3s on one side of the carbon atoms, double bond, and we have the hydrogen atoms on the one side of the carbon-carbon double bond. So this type of the isomer is called a cis isomer. But this compound has its already a specific name that is called a butene, which means we need to add another word here that is the isomer name, which is cis here. So cis butene. So this is a cis isomer of butene. Now we go the other configuration of this molecule. Over here, by comparing this molecule with the first one, you can see that in this case they have just rotated the right hand side of the carbon-carbon double bond. It is rotated this side. So as a result, hydrogen has gone to the upper side and methyl go towards the lower side. So what happened that hydrogen's atoms are now on the opposite directions to each other, and similarly CH3s are on the opposite direction to each other. So we have the trans isomer of the same compound, trans-butene. So that's how we represent the cis form and the trans form of the molecules. It has been observed that if there is any compound which will contain n number of the carbon-carbon double bonds, n number of carbon-carbon double bonds with different groups, definitely, then it will have this much number of the geometric isomers. This is representing, n is representing number. Let's suppose if we have one carbon-carbon double bond present in the compound, then the number of isomers formed will be 2 with the power 1, that gives 2. And if we have 2 here, then 2 with the power 2 will give 4. Sorry, 2. This is 2. 2 with the power 2 will give 4. So that's how the number of isomers increases as we increase the number of the double bonds. So we have discussed one example in which there is cis and trans isomer. Now let's go through example in which there is no cis trans isomer. First look at this. This compound has methyl groups on both sides of the one carbon of this carbon, which is showing double bond. It has two similar groups present on each side. So this type of structure cannot give the cis trans isomer. इसमें ना ही cis होगा ना ही trans होगा. Since we have to show similar sides, although we can see similar directions of these two groups, but there is no similar side on this side. वो तो हमने तो वो इसी बेस पे बता दिया कि जब वो ग्रुप से सेम हो जाएंगे तो उसका सिस होगा नहीं, उसका ट्रांस भी नहीं होगा. So cis trans cannot be given by this compound. Look at here. In this compound, we have Cl on both sides of this carbon and hydrogen on both sides. So again, same rule. They have similar type of the atoms on each side of the carbon. So that's why it will not give cis trans. Over here, we have the hydrogen on both sides of this carbon. So because of this, it cannot give the cis trans isomer. इसके अलावा, let me raise it. In this case, we have carbon-carbon. We can see that there is chlorine and there is a chlorine over here. So tell me, would this compound give cis trans isomer? Would this compound give cis trans isomer?
No, sir.
Why not?
No double bond.
Exactly. There is no double bond present here. So the requirement is not fulfilled. Same is the case here. There is no double bond present, so no cis trans. Now again back here, हमने अभी बात की थी इस कंपाउंड की. Now we will discuss this compound. इस compound में you can see that the A and A are on one side of the carbon. ये similar हो गए, but on two different carbon. एक carbon की बात नहीं हो रही, दो different carbon की बात हो रही है. Similar हो गए, और इसके दोनों बाकी जो groups हैं, they are not similar to each other. But even then, it will be considered to have cis trans isomer. उसकी reason ये है कि we should have at least two similar groups to be present on one side of the carbon-carbon double bond. We say across the carbon-carbon double bond, जो है, two similar groups should be there. So that's why it will have cis trans isomer, even though the other two are not similar. So these two are similar. अब इसका trans कैसे होगा? The A will come over here and D will go over there. So A will be opposite to other A. So as a result of this, we will have trans isomer. Now in this case, you can see that all of the groups are different, but it will still have the cis trans isomer. The reason is that यहाँ पे हम देखेंगे कि A और B का डिफरेंस आपस में कम है, और यहाँ पे E and D का डिफरेंस आपस में कम है, जबकि B से D का डिफरेंस ज्यादा है. This, if you know the alphabetical order, A, B are next to each other, E and D are next to each other, but B and E, there is a difference. They are not next to each. Sorry, B and D, they are not next to each other. There is another difference between them. There is another member in between them, that is a C. So बस कहने का मतलब यह है कि we will look into different examples where this type of the rule will be applied. These three are basically also the rules. You can say these are the rules which will be applied to check the presence of the geometrical isomerism. So these three rules can be applied, and these will give you the geometrical isomerism. We have now another example, but this example belongs to the ring compounds, the cyclic compounds. For example, here, this is a 5-membered ring compound, like a compound which has 5 carbon atoms in the ring. Now, in this case, we have the CH3 group present over here. We have the OH group present over here. Similarly, we have CH3 over here and OH over here. Now, these will have cis trans isomer because of the direction of these bonds. This bond is showing that the bond is coming out of the plane, and similarly, this bond is showing that it is coming out of the plane. Since both the bonds are coming out of the plane, so because of this, it is a cis isomer of the compound. On the other hand, this molecule has one bond coming out of the plane and the other bond going into the plane. So that's why it is a trans isomer. So you have to learn this thing. Now about these three configurations. In this case, This line indicates the bond on the plane. This bond indicates into plane. So here, these two carbons are joined with each other. This carbon is connected to this carbon. So the groups present on this carbon has structure like this, that CH3, both the CH3 are going, both CH3 are present on the plane and present vertically up. They are similarly placed in the upward direction and they are on the plane, and they both hydrogen atoms are going into the plane. They are both, since there is a dotted line which indicates they are into the plane. So that's why it is cis form. Now, in this case, by comparing this molecule with this one, you can see that they have flipped the position of this hydrogen and this CH3. So when it is flipped, it is going into the plane and it is present on the plane. So they are uh, basically sort of trans isomer, and its hydrogen is going into the plane and its hydrogen is on the plane. So they are trans isomer. हमने bonds की directions भी check करना है कि ये जिस तरह से into the plane and on the plane की बात हो रही है, इसी तरह ये on the plane and into the plane की बात हो रही है. So on this basis we say they are trans isomer. Now in this case, they both the groups are present on a single carbon, not on two different carbons or adjacent carbon. Instead, they are present on a single carbon. So for this reason, they do not contain the cis trans isomer. Ring वाले जो compounds होते हैं, they are not frequently coming in the questions. They are just few questions of the ring compounds. लेकिन we have to go through the ring compounds to give the answer to those questions. I have explained the 5-ring structure. Now this is the 6-member ring compound. Now in this case, the OH groups are, both of them are OH groups and they are both coming out of the plane. So that's why it indicates the cis form of the compound. And over here we have one OH coming out of the plane and the other one is also coming out of the plane. So it is also cis form. क्योंकि दोनों की directions एक तरफ से, it is both going into the plane and these both are coming out of the plane. Now in the case of transform, one bond is going out of the plane and one is going into the plane, and over here out into the plane and out of the plane. ये जो नीचे है ये बेसिकली एक थोड़ी सी कॉम्प्लिकेटेड डायग्राम है ये भी 6 कार्बन एटम्स की, but we will not discuss these type of the structures since they do not come in the questions. So what happens because of these geometrical isomerism, that they have different chemical and the physical properties. Now this example of 4-member ring, over here you can see that they both are cis form, this one and this one. इन दोनों में क्या क्या चीजें हमें नजर आ रही हैं? The carbon atoms at the opposite directions have the similar groups coming out of the plane, just like in 5-member ring and 6-member ring. Both are coming out of the plane. और यहाँ पे they are present on those carbons which are connected to each other directly. They are adjacent. इसको हम कहते हैं adjacent carbons, next to each other. इनके ऊपर भी same groups attached हैं and they are present on the plane. So because of this, they are cis form. They are present on the plane, so they are cis. अब trans की हमारे पास क्या क्या condition नजर आ रही है? Over here, the COOH is coming out of the plane and this COH is going into the plane. So opposite directions. और यहाँ पे both COOH are present on the plane. So that's why they are trans isomer. इसमें उसमें difference ये है. This one, ये एक ही side पे थे. Both the carbons atom were present on the same side, but these carbon atoms are present on the opposite directions. तो उनके ऊपर जो COH है उनकी उनकी भी सिमिलर ही हमें यहाँ पे प्लेसमेंट नजर आ रही है that they both are on the plane, but the carbon atoms are at the opposite directions. They are at the opposite direction to each other. That's why they are transformed. So you just have to learn in the same way. After this comes the optical isomerism. Optical isomerism में हमारे पास we have a type of a carbon which is bonded with 4 different atoms or group of atoms. Within an organic molecule, if a carbon is bonded to 4 different types of atoms or group of atoms, then that carbon is called the asymmetric carbon. It is called asymmetric carbon. Its other name is called chiral center, and it is also called chiral carbon. These are all different names. Asymmetric carbon, chiral carbon, or chiral center. It is that carbon which is bonded with 4 different atoms or group of atoms. For example, over here, this is an example of a compound in which the carbon is bonded with 4 different groups of atoms or atom. For example, this is CH3, this is hydrogen, just one atom, this is group of atoms, and this is group of atoms. ये ऐसे कार्बन की बात हो रही है जिसके साथ 4 डिफरेंट चीजें कनेक्टेड हैं. तो क्या होगा? एज अ रिजल्ट ऑफ दिस, such a molecule will give optical isomerism. Such a molecule in which there is a chiral carbon or asymmetric carbon, it will give optical isomerism. By optical isomerism, we will have 2 isomers. One isomer will be called the dextro-rotatory isomer, and the other one will be called levo-rotatory isomer. The dextro and the levo. Dextro-rotatory भी कहते हैं इसको, levo-rotatory भी कहते हैं. And these are indicated by the letters D, L, or their other symbol is plus and minus. Plus for dextro, negative for levo. And what their property is, the dextro-rotatory or dextro isomer is the one which can rotate the light to the clockwise direction. It has the ability to rotate the light clockwise direction, and the levo has the ability to rotate the light in the anti-clockwise direction. Clockwise direction can also be regarded as the right direction and anti-clockwise as left direction. So these isomers have these properties. We, on the other hand, also say that जो optical isomers बनेंगे, जिनके हमने नाम बोले हैं, these are enantiomers of each other. We call them enantiomers. They are enantiomers of each other. By enantiomers, we mean that those 2 compounds are like mirror images of each other. They are mirror images of each other, and such mirror images which cannot be superimposed on each other. मैं repeat करता हूँ सारी story को. An organic molecule in which a carbon is bonded with 4 different atoms or group of atoms, that carbon will be called as chiral carbon or chiral center or asymmetric carbon. As a result of this, that compound will give 2 optical isomers. One optical isomer is called levo, the other one is called dextro. And these 2 compounds are also called enantiomers of each other. And these enantiomers are basically the mirror images of each other which cannot be superimposed onto each other. I can give an example with my hand. Let's suppose this is my right hand, this is my left hand. If I uh, if I want to superimpose this right hand on this left hand, I will simply put this hand onto this one, and they are totally superimposed on each other. They are merged on each other. There is no difference I can find between them. If I look from here, it is same. If I look from here, it is same. But if I take the mirror image of my right hand, it will have an image like you will see on the mirror. You will see that this thing, this hand cannot be superimposed on the mirror image of the this hand. So it will be like this. I will have like this image. So mirror images which cannot be superimposed onto each other are called the enantiomer. If these two are our hand, these are not mirror image of each other. If you show your hand on the screen on the mirror, the thing which will be shown on the mirror cannot be superimposed on this hand. This is called enantiomer over here. So I will take an example from this compound. As I told you that this carbon is connected to 4 different atoms or group of atoms. Now, if I want to show a mirror image of this compound, it will look like this. What do we have here? We have that this straight line indicates, this solid line indicates that the bond is present on the plane and it is going upward direction. So similar thing is here. The bond is directed upward. Now this hydrogen in the left molecule, this hydrogen was directed towards right in the diagonal form, right and diagonal. But on its mirror image, ये क्या है? Left और left और diagonal हुआ हुआ है. यही चीज मिरर इमेज में आपको उस तरफ नजर आएगी, मूविंग इन दिस डायरेक्शन. और फिर ये ओ एच जो कि यहाँ पे राइट की तरफ डायरेक्शन है ऑन द प्लेन, वहां पे भी ऑन द प्लेन होगा बट ऑन द अदर डायरेक्शन. एंड दिस सी ओ एच इट इज कमिंग आउट ऑफ द प्लेन. तो मिरर इमेज में भी आउट ऑफ द प्लेन होगा, मिरर हमने यहाँ पे रखा हुआ है. तो ये आपको ऐसे लगेगा कि ऐसे स्क्रीन रखी हुई है और आप इस मॉलिक्यूल को देख रहे हैं. तो अगर कोई चीज बाहर की डायरेक्शन में है तो मिरर में भी बाहर की डायरेक्शन में होगा. तो दिस ओ सी ओ एच इज कमिंग इन दिस डायरेक्शन टुवर्ड्स द राइट साइड. तो यहाँ भी आपको राइट साइड भी नजर आएगा आउट ऑफ द प्लेन. लेकिन ये इसकी टिल्ट जो टिल्ट हुआ है वो राइट पे हुआ है, तो मिरर में इट विल बी टिल्ट टुवर्ड्स द लेफ्ट. नाउ इफ आई वांट टू पुट दिस मॉलिक्यूल ओवर दिस मॉलिक्यूल, मैं इसको सुपर इम्पोज करना चाहूंगा, तो ये एक दूसरे को सुपर इम्पोज नहीं होगा, क्योंकि this thing, this hydrogen will go like this hydrogen. इसको मैंने उठा के इसके ऊपर रखा है तो वहां पे तो OH है, तो this will not be superimposed. In the same way यहाँ पे OH है, इसको जब मैं इसके ऊपर रखूंगा तो OH इसके ऊपर आ जाएगा. तो they are not superimposing into each other. जैसा कि मैंने अपने hands की example दी थी. Superimpose का मतलब होगा same thing are placed over each other and no difference is there. Similarly COH के साथ भी ऐसा ही होगा. यहाँ पे COH इस डायरेक्शन में यहाँ पे लगेगा, it will be COH present over here. So difference आ गया. The only group, yeah, only thing which will be superimposed onto each other will be this CH3. This will be superimposed on this CH3 because both are present on the plane and they are both directed upward. They will be superimposed, but the rest of the group of atoms will not be able to superimpose onto each other. So as a result, we will say that this is the enantiomer of this one and this is the enantiomer of this one, or we say this is the optical isomer of this and this is the optical isomer of this. So as a result, we will say that if we have one asymmetric carbon, this is the asymmetric carbon or chiral center. For every one chiral center, we have two optical isomers. For one chiral center we will have two optical isomers. So this is the thing about the optical isomerism. We will consider more examples here. For example, this compound. Now this compound is also bonded with four different groups. We have NH2, CH3, chlorine and hydrogen. अब इसके भी अगर हम मिरर इमेज कंसिडर करें तो एक मिरर इमेज कुछ ऐसा होगा, दूसरा उस तरह का होगा. सॉरी, इस कंपाउंड को यहाँ पर तो 2 डायमेंशनल फॉर्म में रिप्रेजेंट किया गया और यहाँ पे इसको जब 3 डायमेंशनल फॉर्म में रिप्रेजेंट किया तो फिर इसके आगे मिरर इमेज रखा गया. सॉरी, इसके आगे मिरर रखा गया. इसके आगे जब मिरर रखा गया है तो उस मिरर से जो इमेज बना है वो इसका मिरर इमेज है. इट इज इन द 2D फॉर्म, इट इज इन द 3D फॉर्म. 3D फॉर्म में इसके जैसे हमने मिरर रखा तो उससे इसका मिरर इमेज इस तरह का बना है. Now, if you try to superimpose these two forms onto each other, they will not superimpose. The NH2 of this molecule will go over there, the Cl will go over here. So they will definitely not superimpose. So we say that two optical isomers are formed from this molecule. और कैसे पता लगा था? क्योंकि इसमें कायरल सेंटर है. कायरल सेंटर या कायरल कार्बन होने की वजह से पता लग जाएगा कि that molecule will give optical isomer. और कंपाउंड में एक से ज्यादा कायरल सेंटर एग्जिस्ट करते हैं और हो सकते हैं. अभी तो हमने वो एग्जांपल ली जिसमें सिर्फ एक ही कायरल सेंटर है, एक ही कायरल कार्बन है, बट दोस मॉलिक्यूल व्हिच विल हैव मोर देन वन कायरल कार्बन्स, they will produce equally different number of the optical isomers. If we have 2 chiral centers, we will have 4 optical isomers. If we have 3 chiral centers, we will have 6 optical isomers. We will consider more examples. इसमें एग्जांपल देखने. We have 2 optical isomers. How do we know that this carbon is bonded with hydrogen, with chlorine, with bromine, and this whole large molecule? This one is connected with this whole molecule. कैसे पता लग रहा है that this carbon is connected with this carbon, which is bonded with hydrogen, which is bonded with OH, this carbon bonded with C, hydrogen, hydrogen, hydrogen. So this whole is a molecule connected with this carbon. So different groups इसके लिए हो गए. इसी तरह से लेफ्ट वाले कार्बन के लिए हम कहें तो this left carbon is bonded with hydrogen, with OH, with this whole CH3 molecule, and on the right side it is bonded with this molecule which contains carbon, hydrogen, bromine and chlorine. So as a whole this molecule has 2 chiral carbons. So as a result हम इसके अगर 3D फॉर्म शो करें तो उसका जो मिरर इमेज है will not superimpose on this one, और इसने मिरर इमेज इसके बेस पे बनाया है और इसके बेस पे बनाया है. इसके बेस पे यहाँ पे बना हुआ है और इसके बेस पे नीचे बना हुआ है. तो just to tell how their isomers are not superimposing on each other. So we have 2 chiral centers and as a result we have 4 optical isomers. We have optical isomer 1, we have 1, 2, 3, and this one is 4. So that's all for today. We'll continue from here in our next class. Till then, take care and Allah Hafiz everyone.